September 12, 2025. It began like any ordinary morning at the Solar Heliospheric Observatory, until a technician monitoring the SWAN instrument froze mid-scan. On his screen, something enormous blazed across the darkened object, moving fast, impossibly fast, and shining with a tail so vast it seemed to slice the heavens apart. 5 times the width of the full moon, brighter than anything seen in decades. For a moment, the team thought it was a glitch, but when secondary instruments confirmed it, silence filled the room. Within hours, the world's observatories were buzzing. The data was clear: something colossal had entered our solar system, an object from deep interstellar space, moving with purpose. Yet before scientists could even comprehend what they were seeing, another signal arrived. A second object racing toward the sun from the opposite side of the sky, both on course for a near-simultaneous solar encounter, only days apart. The odds of this happening by chance were beyond astronomical. The official line was simple: to new comets, a cosmic coincidence. But behind closed doors, researchers whispered a different question. What if this wasn't coincidence at all? What if something had engineered it? By the end of the day, the first was confirmed and given a name: C-2025R2, SWAN. Within just 24 hours, amateur astronomers around the globe joined the chase, pointing their telescopes toward Virgo. What they found stunned them. A tail so vast it stretched beyond the edge of camera frames, its glow steady, unblinking, too consistent to be natural. SWAN wasn't just bright, it was defiant, holding its shape and intensity as though guided by design. The International Astronomical Union made it official on September 13th. But even before the announcement, every major observatory was already tracking it. The numbers didn't add up. Most comets flicker as they spin and break apart. SWAN's brightness was constant. Its geometry was perfect. It was the kind of precision nature rarely achieves on its own dot by the weekend. Every astronomy forum on Earth was ablaze with debate. Some said it was the brightest object since Hale-Bopp. Others whispered that it might not be a comet at all. The data hinted at something larger, something powered. Yet even as astronomers scrambled for answers, another discovery reignited the mystery. Days before SWAN appeared, another inbound traveler had been spotted: 3i, Atlas. Unlike SWAN, Atlas wasn't dazzlingly bright. It was puzzling. Early readings from the Atlas survey revealed an object unlike any ever seen. Its composition didn't match any known comet. Nickel dominated its spectrum, with virtually no iron on Earth. Nickel is forged in extreme environments, furnaces hotter than the cores of stars. But in space, it's almost never found in isolation. The readings were so bizarre that some labs refused to believe them, assuming an instrument error. But when independent observatories confirmed the data, disbelief turned to unease. Then came the next revelation. Atlas wasn't releasing water vapor like normal comets. Instead, it spewed carbon dioxide 5 times more than water, a signature so strong it drowned out everything else. The 4.3 micron CO line pulsed with unnatural strength, almost rhythmic. And then astronomers noticed something that made even the skeptics go quiet. Atlas wasn't moving smoothly. Its trajectory showed 3 distinct accelerations, each perfectly timed, to weeks apart, each one accompanied by a sudden flash of brightness and a color shift in its tail. Red, then silver, then red again. It was as if the object had fired a thruster. The data logs were rechecked again and again. Observers from different continents all recorded the same pattern. The pulses were too abrupt to be natural, too powerful to be caused by sunlight alone. When the numbers were run through energy models, the result was staggering. Each acceleration would require the output of 10 nuclear power plants. 10 gigawatts, coming from a body no larger than a city. Official statements labeled the findings as unusual outgassing. But the term didn't convince anyone paying attention. Online, whispers grew louder. Some said it was an alien probe. Others called it an ancient relic from another civilization drifting back to life. And while the debate raged, something even bigger was unfolding. SWAN, the colossal newcomer, was outshining everything in the sky. Its energy output was beyond comprehension, an estimated 10,000 gigawatts, greater than the total electrical power used by all of Earth. Its light didn't scatter like dust or ice. It reflected like metal. Not just any metal, but a nickel-cobalt alloy, the kind used on Earth for heat shields and spacecraft hulls. When amateur spectroscopists released the readings, the term nickel-cobalt hull spread like wildfire across astronomy chat rooms. It sounded impossible, yet the data didn't lie. SWAN wasn't breaking apart under the sun's radiation, it was holding firm, glowing with mechanical precision. Something about it felt alive, and that wasn't even the strangest part. As Swan and Atlas drew closer to the sun, their orbits tightened, nearly overlapping. They were approaching perihelion just 3 days apart. Atlas on October 17th, Swan on October 20th. The distance between them would shrink to 50 million kilometers, closer than Mars ever gets to Earth, and right when the world needed to see them most. Nature itself would hide the show. From October 8th to the 18th, Earth's view of both objects would be completely blinded by the sun's glare, a 10-day blackout, when no telescope could watch what happened next. To mysterious objects arriving from opposite ends of the galaxy, converging behind the sun where no human eye could follow. Coincidence? Or a rendezvous deliberately timed to take place where no one could see? Nobody had an answer. But as the blackout approached, one thing became undeniable. These weren't ordinary comets. Their timing, their chemistry, their impossible power had all pointed to something else. And somewhere in the silence between their trajectories, humanity began to wonder, what if they weren't visitors at all? What if they were returning? Then came the first visual anomaly, an inexplicable halo, a silvery aura encircling Swan's core that shimmered like liquid light. At first, astronomers dismissed it as a reflection artifact, a trick of solar glare or lens diffraction. But as the days passed, the halo persisted, its shape subtly shifting, pulsing, breathing almost. The spectrum data told a different story. It wasn't reflected sunlight at all. It was plasma-ionized particles forming a perfect containment field, an electromagnetic sheath that seemed to repel solar wind and cosmic debris. That's when someone whispered the nickname that would stick the fortress. Unlike Three-Eye, Atlas, nimble and erratic, Swan moved with deliberate grace, slow and methodical, like a colossal warship gliding through space. Its tail was vast, stretching millions of kilometers, yet even that wasn't normal. It pulsed tiny rhythmic thrusts, microbursts of light that appeared far too controlled to be random. Spectral imaging revealed directional shifts synchronized to precise intervals. Like an engine firing in code, every pulse altered its trajectory by mere fractions, but over time, those fractions spelled intent. As the numbers came in, something even stranger emerged. Swan's orbital period was calculated at roughly 22,554 years, a timescale that dwarfed human history. It had last passed near the sun when glaciers blanketed half the Earth, and the first flickers of civilization were still buried in the future. If this was engineered, then it had been traveling on a preset course for longer than humanity had existed. And now, impossibly, it had arrived in the same corridor as Atlas during the one time a year when Earth's telescopes were blinded by the sun's glare. Coincidence was no longer an acceptable explanation. The data fueled wild theories. Some scientists argued Swan wasn't a comet at all, but a vessel armored, self-correcting, and shielded by advanced plasma technology. Others suggested a natural phenomenon so extreme it defied existing physics. Whatever it was, its sheer energy output dwarfed anything seen before. Swan's luminosity alone matched small stars, its stability perfect even under intense solar radiation. The fortress wasn't just a name, it was a description, and yet, the deeper researchers dug, the more the mystery bled into something that felt deliberate. To massive bodies, one following a 20,000-year path and another screaming in from interstellar space, arriving almost simultaneously. The odds were less than 1 in 10 billion. The geometry, timing, and blinding solar alignment painted a scenario too elegant to be random. People began to whisper about a mission. One camp proposed a startlingly logical theory, a solar rendezvous. Maybe both Swan and Atlas were part of a larger operation, using the sun as a refueling station. In deep space engineering, solar flybys are standard procedure: gravity assists, power boosts, energy audits. If these were probes, the sun was the perfect hub for data transfer, energy collection, or synchronization. A cosmic pit stop, billions of years in the making. But another camp was less optimistic. They saw Swan not as a refueling ship, but as an enforcer, a retrieval unit sent to intercept or disable a malfunctioning drone. Atlas. Others speculated an ancient conflict, rival factions meeting in the solar system after eons of dormancy. Energy readings suggested both objects carried staggering reserves. Atlas, emitting nearly 10 gigawatts, Swan almost 1,000 times more. Such power wasn't the hallmark of passive travelers. It was the signature of control. Still, the most haunting idea of all was the audit theory. It began with Oumuamua in 2017, the first interstellar visitor humanity had ever detected. Then came Atlas, now Swan, each more complex, more deliberate. What if these weren't accidents, but phases? A chain of increasingly advanced probes responding to Earth's growing radio noise, checking on a young species broadcasting its presence into the void? If so, Swan wasn't here by chance. It was here on scheduled dot, and if that schedule aligned with a 554-year cycle, it wasn't just astronomy, it was history repeating itself. The last time Swan's orbit swung close, ice sheets covered the northern hemisphere. In that same epoch, layers of ash and dust buried in Greenland's ice cores hint at cataclysmic events. In the sky, bright streaks, falling fire, perhaps a celestial visitor that ancient eyes recorded not in writing, but in myth. In southeastern Turkey, there's a place that may hold those memories. Göbekli Tepe, older than the pyramids, older even than written language. Its carved stones show animals, stars, and strange swirling shapes that some researchers claim map celestial patterns, possibly even long-period comets. Could one of those be Swan? Most scientists reject that link, calling it coincidence, but others can't ignore the timing of alignment between the monument's construction and Swan's last return. To them, it's not mythology, it's memory. Whether or not that's true, the implications are staggering. If Swan has been here before, maybe we've seen it and just didn't understand what we were seeing. Then came the silence, from October 8th to 18th. Every major observatory from Hawaii to Chile to Spain announced a routine solar conjunction downtime. Officially, it was a safety precaution to avoid pointing telescopes too close to the sun, but off the record, internal memos told a different story. Space Command and the European Space Agency ordered full data lockdowns. No imaging, no radar, no optical tracking of Swan or Atlas. Requests for access were denied, even from top-level researchers. Every public feed went dark. The blackout was total, but where the institutions went silent, the amateurs rose up. Bell Gray, a veteran orbital analyst, issued a quiet rallying cry across astronomy forums and encrypted channels. Keep watching. Log everything. Before it's gone. His message spread like wildfire. From Portugal to Australia, backyard astronomers linked their rigs into a makeshift global network. Some hacked weather satellites, others repurposed radio telescopes. They shared every flicker, every anomaly, every whisper from the sky. This was no longer just science, it was defiance. With the agencies mute and the official feeds dead, the search for truth fell to the people watching from rooftops, fields, and mountaintops. Ordinary citizens became humanity's last eyes on the unknown, and as the blackout deepened, one truth became undeniable. Two anomalous visitors had entered the inner solar system together. One ancient, one alien, both beyond explanation. Whether their meeting was a coincidence, a message, or the prelude to something far greater, no one could say, but the sky was no longer quiet. And when the silence finally breaks, it won't be the government labs that hear it first. It'll be us.